All right. All right, welcome back, everybody. Let's see. So let's see, we are on the second half of the semester, right? And the focus of the second half is the server side of a client server application, right? We focus the first half of the semester in building a client side of a client server application, which consisted of a React JS user interface, right? That interacted with the user entered data, interacting with forms, buttons, keyboards, and we collected that information and used JavaScript running on the browser, right, to handle all those events that generated by the user to add content, right, delete content, update content. But it was not permanent, right? When you refresh the screen, all those changes went away. So in this second half of the semester, we're introducing a server, right, Node.js server that the user interface can rely on to post or put or delete data, right? So that the server can make it permanent, right? Either temporary in the memory of the server, so it's permanent, while the server is running, or you could save it to a file. And now saving it to a file, right? That would be almost like a database, right? A custom-made database where you can save to a file, load from the file, search data from the file, and a much more efficient file system that saves data to a file, right? Much more efficient implementation of that is a database, right? And so that's going to be the focus of this week and next week. We'll be introducing our last tier in a multi-tiered application, right? A database. So we're going to be introducing MongoDB today and see how we can integrate Mongo with our server, our Node.js server, and provide a end-to-end storage solution, long-term storage solution, right, for our client server database application. All right. So the assignment was going to be due later this week. There have been some syntactical errors and also in the code that was shared with the class. So we're moving the due date to the beginning of next week, right? So I will make some corrections to the source code provided in the assignment, right? And I will provide that. I will highlight what might help you, fix whatever issue you might be having. Also, some folks are having a challenge deploying this to Render.js or AWS, right? I didn't seem to have any problems, but I'll help those during office hours. Please see me perhaps tomorrow morning or later in the afternoon. Right? If you're still having problems deploying to Render.js or AWS, we'll help you out to fix those issues, right? Let's see. Question on the chat. Hi. Where can we find the recording of last Thursday's? Oh, I thought I made it available. Maybe not. I'll make it available right after class. So can we discuss how should we store user sessions? Yeah, we'll discuss user session. It is part of the upcoming assignment. And the upcoming assignment introduces how to work with users, being able to log in, register, creating accounts, profiles, and things like that. You know about the env file also in the render. And we'll talk about env as well. Yeah, so that's will also be today's lecture as well. The exam, there have been some questions about the final exam. So the date that we have here, which is the 15th, right? Friday the 15th. That's for the undergrads. They have a fixed date that is available to them. Where all the undergrads take the exam the same day, that particular time and day. For the classes, the online classes, it's the date starts on I believe the 11th, right? That week of the December the 11th, and it goes on for several days, right? The exam, just like for exam 1, exam 2 will be available for several days, right? And you can take the exam, any day during that week, right? I think it'll be available like 3 or 4 days, right? So starting on Monday the 11th, right? And you can take the exam any day that week. What else? And yeah, grades are due the following Monday. Yeah, so I'll make the recordings available. I must have slipped my mind, but yeah, I'll make that available. Also, I have been sharing the source code for the assignment 5, right? Makes you can reuse that source code as your own. It might be useful for your assignment as well as for the upcoming project, right? Yeah. So last time we met, we did a demo on how to get started on the project. We didn't cover any new material. We just illustrated some of those requirements, right? How to interpret, interacting with a third-party API, be able to search data from the API, and then display that data, inquire more details about the data. So I'll upload that. I'll make it available. I thought I did, but maybe I forgot. So yeah, so today we're going to the focus of today is MongoDB. Right, so we're going to be discussing how to interact with Mongo, right? How to integrate it with our client server application. We'll have a sneak peek at the upcoming assignment, and we'll work through some of those labs together. Right. Again, I will share the source code for assignment 6. Right. And again, you can use it as your own, right, for the assignment, for even for the project. This material that we'll be covering today will be useful also for your project, I believe. Okay. All right. Any other question? So yeah, next week is Thanksgiving week. So we'll be meeting the first half of the semester of the week. We won't be meeting the second half of the week. Obviously, the assignment 6 due date is pushed off, well after Thanksgiving, right? So not the Thursday after Thanksgiving, but the Monday after, even after that, right? So I'll update the due dates on the assignments. What else? Oh yeah, you should all be working feverishly towards your project, right? You do have quite a bit of set of skills that you can already be working on, right? You already have HTML, CSS, React.js, JavaScript that you can create a demo, a prototype of what your application might look like. You can already start styling it, making it look professional, right? And you can mock or use dummy data, right? That start adding the your reducers, your state variables, right? Using JSON objects, JSON files, right? That would represent the data that you would expect, right? For assignment 5, node server at repo. I didn't create a branch A5. I did it in the main branch. I mean, that's fine. You can for assignment 5 in Node.js, that's fine if you use the main, since you're not really overriding any other branch before that. the intent of having multiple branches is that we want you to be able to keep multiple versions of the servers and multiple versions of the front end, right? So that you can keep working on the next assignment without, overwriting any of your previous assignment. There's no need to change the due dates on the quizzes, since it's material that we have already covered. Yeah, they're unchanged. Actually, I was thinking of adding a couple more quizzes. All right. Yeah, so let's get started. Right. So the upcoming assignment is all about database using the Mongo database. So let's take a look at that. So this is a sneak preview of the upcoming assignment, right? Which I will release later this week. But you don't really have to start working on it until next Monday, right? But nevertheless, I'm going to start covering the material, since I think it's very relevant. Especially since you do need to start working on your projects, and this is a skill that you'll definitely need for the final project. Okay. So we are working on something that has this structure, this architecture, right? In the first half of the semester, we focused on this side, right? The client side of a client server architecture, right? And that client was implementing a user interface, right? That used by human users that interacted with a graphical representation of an application, right? And it had its own state, right? It maintained its own state. It did all the navigation between multiple screens, multiple components, and so on, right? And so in the last couple of weeks, we've been adding, right, the server side of the client server application, right? And we learned about, right, that we were able to move the state management, right, replicate some of that. We moved it over to the server, right? So the data that we were using collected in a so-called database, right, that used to live on the client, we moved it over to the server, right? Because we identified some limitations of what you can do, right? In particular is that you couldn't do, the data was not persistent, right? That if you refreshed the browser, you lost any of the state changes in the application, right? So we moved it over to the server, right? And we made the data on the server available through routes, right? We made it available through HTTP routes that the client could then use to integrate, right, with that data, so that it could retrieve the data, it could put data, it could post data, it could delete data, and then the server, implemented those operations, right, by manipulating the data on behalf of the client, right, and then responding to the client on whether it was successful or not, right, and what the new state was. Okay, but it was not really persistent, right? We saw that the changes were persistent as long as the server was up and running, right? It was all being stored in the memory of the server. And perhaps an alternative solution would have been to store the data to a file. That would have been absolutely more persistent, since even if the server would have crashed, right, when the server would boot up again, it would be able to read the data from the file, right, and then have everything up and running again. But then, if you are going to be reading and writing to a file system, right, might as well just add a database, right? Since the specialty of a database is, right, to give you a structured mechanism by which you can query, structured data, stored in some binary or file, a file system, right? And it's very efficient. It's their bread and butter. That's what they do. So we're going to be adding a database, right? Because we want to make these changes permanent for long-term storage solution. And we're going to be using a non-relational database called MongoDB. Again, we could have chosen any number of databases to do this, just like we could have chosen any number of servers or any number of user interface solutions, right? Now, but this particular choice of client technology, the server technology, and the database technology, this technology stack, right? It's often referred to as MERN, right? Where it's Mongo expressed with Node, right? And React, right? So that's the acronym. It's a well-known acronym of choices of technologies in the various tiers. Okay, and they work very well together. Right? They can all rely on the data representation, the data storage, right? In the data for the front end, the data in the middle tier, and the data stored in the database, right? All stored in the same format, right? It's JSON, right? Which is JavaScript object notation. It's a format that is friendly to the languages that we are using for development, right? We're using JavaScript, right? And so JSON already plays nice with those language choices. And Mongo also plays nice with JSON, since it's a native storage format, right? Is JSON, right? You stores everything in JSON objects in there, right? Now, there's a slight difference in the acronyms and the jargon and the terms that we use in non-relational databases. For instance, in relational databases, if you come from that world, right, we usually talk about schemas and tables and records and rows, so the equivalent to those terms, right, in the non-relational Mongo world is that instead of using tables, right, here we use collections, right? And you can think of a table as a collection of rows, right? And so in Mongo we use collections, right? Whereas in a relational database, the tables contain rows, and each row represents a record. The fields or the columns, right, in those tables, right, represent the data that is stored in each one of the records, and those fields can contain data that typically is just you can only store primitive data types, right? So strings, integers, booleans, right, dates, and only recently, right, you can now store complex data types as well, such as XML or even JSON right now, right? But in Mongo, the collections also contains things that are equivalent to records, but we don't call them records. We don't call them rows, right? Just like we don't call them tables, we call them collections. Instead of records or rows, we say documents. So a collection of documents, just like a table of rows or a table of records, right? In Mongo, we say that they are collection of documents, right? And these documents, right, are formatted, right, in MongoDB, and most non-relational databases, it's formatted as JSON. So these documents are JSON objects, okay? And these objects have properties, which are the equivalent of fields, right, or columns in a relational database. But unlike relational databases, where most data that you store is primitive data types, here, right, the properties in an object can be arbitrarily complex, right? You have objects that contain properties that contain other objects, that contains arrays, and those arrays can contain objects, and those objects can contain arrays. So the data that you store in an object, right, in a record, right, in a document in MongoDB could be arbitrarily complex, right? So today what we're gonna do is that we're going to take the data that we were using in the Node.js, right? All those objects or those arrays that represent the courses, right? Represent the modules, the assignments, right? Those we're going to now add them. We're going to import them into MongoDB, right? We're going to put them where they should have been all along from the very beginning. Okay. So it has been moving right from the front end to the middle tier, and now in its rightful place in the database. Right, we're going to put it those arrays of objects. Right, we're going to put them in MongoDB where they live, where they should live. Okay. Yeah. Okay. So that's where we're going to be. All right. So yeah. So also this I'm going to use this graphic quite a lot in the assignment, right? To tell you a little bit. I'm going to use it like a map, right? That we're going to first work our way from the left, from the right-hand side, work our way towards the left, right? We're going to start playing around first with Mongo. We're going to connect to the Mongo database, right? We're going to create several collections, right? We're going to import the data in there, right? And then we're going to work our way on adding to the HTTP server that we have, the Node.js server. We're going to add the capability of being able to interact with that database, right? So how do we, when we put the data here on the server, we had to create routes, right, that would allow clients, right, to come in and ask for that data. We're going to have to do something similar. We're going to put the data in the database. We're going to have to create several things here. We're going to add a few libraries that are going to allow us to retrieve the data from the database. Okay. So first of all, right, we need to install MongoDB, and you can head over to Mongo, and so there's a paid version of the database, but there's also a free community server version, which is free, right? And you can run it locally on your machine, right? So we're first going to be using this local server, database server running on our machine, but eventually, right, we're going to be using a online cloud version of Mongo, right, called Atlas, Mongo Atlas, which will allow us to store the data on the cloud as opposed to locally on our machine. But for development purposes, it's a good practice to have a local instance of the database, right, that you can develop, run all your stuff, and once you're happy, right, you can move everything over to the cloud. Okay. Also, when you download this, it should also install a client, a Mongo client called Compass, right? And that's it. No, that's not it. Mongo Compass, right? So Mongo Compass is the client application that is going to be able to connect to the Mongo database, right? And we're going to be able to interact with it manually, right? So yeah, so those two things should be installed, right? So once you install it, and the assignment walks you through how to install it. In particular, on Windows, I believe the default installation is that it'll run as a service. And you can go to the services dialog in Windows, right, and see that MongoDB is running. And from here, you can stop the server, start the server. You can configure it so that it starts on its own when you boot your machine, right? And you should leave it like that, right, at least for the remainder of the semester. At the end of the semester, you might want to stop the server and configure it so that it doesn't start automatically. Okay. Or you can also configure it so that you can run it from the command line instead, right? So I'm gonna illustrate this this part, right, where we're going to install it. Well, it's already installed, but I'm going to run it locally from my machine, right, from the command line, right? So typically the server gets installed locally on your hard drive somewhere. On Windows, it'll be under program files, Mongo, right? And that will be the folder where it installs. On a Mac, it installs under user local, right? So we can do ls user local Mongo. So that's where it installs, right? And installs under this directory, right? And under there, you'll find a bin directory, right? And that bin directory is where you can find the executables, right? Even on Windows. So on Windows and on Mac, you'll find a bin directory, right? That if you look at the content of the bin directory, it'll contain two executables, right, of interest. One of them is the Mongo S or Mongo service, right? That is used for running your Mongo database as a service, right, in the background, right? And so it starts at when your machine boots up, right? The server already boots up with it, so that it's already running when you finish booting. On a Mac, you would be able to see it on your settings. It would appear under one of these settings that you can start and stop the server. I don't have it running as a service on a Mac. On Windows, you would see it on the device and on the services dialog. You can see it running, and you can stop it from there. So I'm going to demonstrate how to run this locally, right, manually, as opposed to as a service. For that, we need the second executable here. It's MongoD, right? Mongo daemon, right? That we can start it from the command line. Now, this version, the MongoD, needs to have a directory where to store the files, its own files, right? When you create a database and you insert data, it stores all that data in a file, right? And you have to tell it where to dump all that data. So what I did is I created a folder called data, right? And that's where I'm going to tell it to store all these files, right? So to run it, we can just run MongoD, right? On Windows, it would be mongod.exe, right? So let's run it. So we can say user local MongoD bin MongoD. Okay, so that's the executable. Now, I need to tell it where to dump its files, right? If you just run it like this, right, it'll start for a second and then it will stop, right? And it'll come back to the command line. So it just did not start the server, right? You have to tell it where to find your data directory, right? And now notice that I'm going to the whole directory structure like that to run MongoD. You can also, right, add this path, right, to your environment path variable, right? So that you could just type MongoD. You could just type MongoD, it'll find it in your path, and then you will run it. I haven't done that, right? So if I just say MongoD, it says that it can't find it, right? And so you can either add the whole path to your environment variable, right? So that it'll find it, or you can just type the whole thing, right, and tell it where the executable is, right? That's what I'm doing. So this won't work unless you tell it where to find the data folder. So to do that, you use this option, command line option, db path, right? Path, and you tell it what directory to use. So it's data. So this time it was successful. So it's running, right? And it's listening at a particular port. It's listening at 27,017, right? So that's a standard port that the server listens at, right? It's waiting for us to communicate with it so that we can store data, retrieve data, right? Query for data, update data, delete data, right? But that's the IP address. Well, the IP address is that it's running on my machine, which is localhost, which the IP address for my local machine is 127.0.0.1, right? And the port that it's listening is at 2717. And that's a standard port that Mongo by default listens at that port. Right? So we can then run our Compass, Mongo Compass, right? Let's bring it over. And we can connect to the server, right, by telling it, right, where to find the server running, right? And we can say, well, it's listening at port, 2717, right? Our local host machine. So we can say connect. So it connects to a database, right, to the server. And on the left side, it lists all the databases that I have stored in my machine, right? So we can create new databases. We can click on plus and give it the name of the database. So because we're working on the Canvas project, I'm going to keep using that same kind of theme for naming conventions. So I'm going to say Canvas, right? And but since there's several sections, I'm going to have a just to distinguish the section, the course, and whatnot. So we have CS 5610, right? And because this is fall 23, just to remind myself which version do I have here. So I'll call that to distinguish this from other Canvas databases. Collections, right? This is kind of like the equivalent of tables, right? Which is where we store the data, right? And so we're going to add several collections, right? One of them is the courses collection, where we're going to import our courses in there, right? So let's create a database. There it is. So we have our new database that was just created, right, with one collection, the courses collection. But again, we're going to have all the data that we have been using as arrays, right? We're going to move them over into collections in these databases, right? So we're going to add several other collections. We're going to need modules, right? We're going to need assignments, and right, I'm going to add a new collection, right, that is going to allow us to introduce a new topic this time around. So users, right? So because Canvas being an application that allows faculty and students and multiple different types of people, right, interact, right? We need to represent those users, right? They need to be able to log in, register, look at their profile. Faculties can do certain things that students can't, vice versa, right? And so I'm going to focus most of our attention on dealing with users of the Canvas application. Now, you can also going to be able to use this for your own project, right? So we're gonna implement this so it's generic enough that it can be used for either Canvas or it can be used for your own project. Okay. So anyway, so let's illustrate how it's that we interact with this, right? We can manually add one document at a time. Or you can say insert document, and you'll see that the format is JSON, right? And also notice that has one property that is pre-filled, already has a preset value. And notice that that property is _ID, right? And it's very similar, or it's actually identical, the name of the primary key that we have been using throughout the last few months, right? We have been using _ID as the primary key for our arrays, our objects, our modules, assignments, courses, right? Our primary key has been _ID, and that was done on purpose, right? Because we knew where we were going, that eventually we'll be using MongoDB, which uses _ID for the primary key. Now the value is slightly different, right? We've been using just plain old strings for the values of the primary keys, whereas this one is it's an object that has a property and then a hexadecimal value, right? A 32-bit hexadecimal value over here. And so that is the real value of primary keys in Mongo. But well, that's fine, because when this makes it out to the client, right, this will be just a string, right? It'll be just be this string here, right? We won't see the OID or anything like that. All right, so let's create a user. So we'll create a username, and we'll say maybe Alice. Then Alice has a password of Alice 123, and she might also have a first name, and this is maybe Alice, and she has a last name of Wonderland, right? And she might have a role in our application where she is a student. Okay, so we click on insert and notice that there it is, right? So we have our first record, sorry, our first document, right, inserted into the database. Everybody good? Okay. So I do give you a set of users that you can use, right? Feel free to use them. I am providing a sample of users. So let's click on that, and which is already formatted, right, so that you can import this cleanly into Mongo, right? So let's download this. So let's go to raw and save this, and I'm going to save it in the I'm going to save it in the project, the Node.js project that we've been using. So 23 fall, and this is going to be in Node. And I'm going to store it in the database. I'm going to store it here in users. Although I already have users. Okay, so I'm just going to JSON. I'm going to override that and say, yep, use that JSON, replace. And so we should already have that. We should be able to see that in our IDE. But let's import it. Let's from Mongo. We're going to say Mongoose. We're going to say Compass. We can say import JSON here. See that? And we can navigate to that database. So it'll be 5610 node database and users. There it is. So like that, import, and there it is. So we have a whole bunch of users already populated, right? Some mythical users from multiple universes, right? Of Lord of the Rings, DC, Marvel, also from various different cultures in in Hindu and Chinese and Christian, Muslim, different various mixture of cultures in there. So obviously, feel free to use your own users, right? Or if you want, you can absolutely use my users. Okay, notice that already how they have populated the primary keys correctly. Right? So I did want to demonstrate, how we can interact with this data manually, right? We can query the database now that it has been stored. We can manually query the database and interact with this data from the command line. So there's a command line down here, right, that you can use to interact with the data. You can create new data, update data, delete data, or retrieve data, right? And so there's a few commands that are pretty standard across multiple vendors, multiple databases. So for instance, if you want to work with a specific database, you can use the command use, right? And use allows you to select which database you want to work with, right? So I'm going to work with the database we just created. It's that one. Right? So now it's all the commands that I'm going to operate on are going to be operating on that particular database with those collections. So these are the database, these are the collections, right? These are the various collections. And so we can, for instance, query and ask, what are the collections? I could even ask what databases are there, right? We can say, show databases, right? And those are all the various databases of which we are now currently using this one. And within that database, we can ask to show what collections are there. And there they are. So assignments, courses, modules, and users, right? So I only have data in users right now, but the assignment will ask you to populate all the other collections, right, of modules, courses, assignments. So let's stick to users for now, right? So we could say, now to operate on any one collection, all those operations, they all start with DB. DB dot, database dot, and then the collection that you want to work with, right? So we only have users right now, so we can say, users. So once you select the collection you want to work with, here's where you would provide all the various CRUD, create, read, update, delete operations on that collection, right? So the simplest of which is reading, retrieving data from the collection, right? So the simplest of which is dot find. So find is a function that operates on the collection that retrieves data from that collection, right? And it's with a parentheses, so you could pass parameters. If you don't pass any parameters, it assumes that you just want all the users, right? So we do enter, it responds, the server responds. So this command went out to the server, right? And then the server responded, right, with this data. Remember, this what we're seeing here is not the database, right? This is a user interface to interact with the database, right? It sends commands to the database through MongoDB protocol, right? And then the server responds, right, with the data, and then we display it here. We catch the response from the server, and then we display it. Well, I mean, this user interface does that, right? So let's try it again. So find is the equivalent in a relational database of the select statement, right? Where you're saying select star from, right, users, for instance, in this case, right? But typically you could also have a where clause, right, in a relational database. You can say, where, and then some filtering predicates, right? Where if you don't provide a where clause, the interpretation is that you want all the records in the table. Same thing here. We didn't provide any filtering logic, right? So it came back, responded with all the documents in the collection. So to provide filtering mechanisms of that, well, I don't want all the, I don't want all of them. I just want a few of them, right? You can provide that in the parentheses, right? And to provide that filter, you provide a JSON object, right, where the properties and values of that object are used to filter, which object do you want, right? So, for instance, we can say, give me only the users whose role, right, is, and then you can say admin, right? Who's an admin, right? And notice only one admin. It came back with Gandalf the Grey, right? He is the admin of this database, right? Or you can say different roles. You can say, give me all the faculty, so faculty, right? And so now it returns everybody who's a faculty, right? Peter and Kidir and you the Great and Krishna and Legolas, right? Aragorn. So these are all faculty. Frodo, right? Galadriel, right? So these are all faculty in our database. Okay. You can also specify multiple. You can specify multiple things that you want to query about, right? For instance, I want to find someone whose username, right, matches, say, this one here, and the password, right, matches Peter Rock here, right? And so if you provide both, then it finds that one user whose username and password match what you passed in as parameters, right, for the username and password properties. Yes, makes sense. So anyway, there are several operations that you can work on users. If I say find dots, notice that not only do we have find, but there's also there's this create for inserting. You can delete a document, right? You can drop the entire collection, right? Just dump it. You can find one item, right? Find one and delete, right? You can update, right? One document, right? You can delete one document. So there's a whole bunch of operations. And so, but these are all manual operations, things that you would, type at this command line to interact with the database, right? So more interesting would be, instead of having to type this manually, right, and having to type, delete, blah, 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 or update, yada, 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 right? Ideally, we would do this programmatically. We would write a program, right, that would send these commands to the database, right? Instead of us manually typing all this, right? Right, to zoom in a command line. Yeah, I don't know that I can show this any bigger. Oh, I can. Yeah, anyway, we're not going to do this manually, right? We're going to learn how to interact with the database through a library that's going to allow us to interact with the database, right? So very much like, so let's go back to our map. Right, so here's a couple of exercises in the assignment that ask you to interact with the database manually. You can also interact with this through Visual Studio Code, right? Code has a plugin, right, that allows you to interact with the database. I prefer Compass, but if you prefer Code, then you can use that too. Either one is fine. Yeah, so let's learn how to program the database, right? We want to programmatically interact with the database, not manually. So for that, we're going to be using a library, Mongoose, right? So Mongoose is going to allow our application, our node application, to connect to the database, right, and send commands, right? Instead of us typing it manually, at the Mongo client, we're going to be able to programmatically send those commands to the server, and the server will respond to us, and we'll be able to capture those responses, right, and then use them in our application. So that's the same kind of challenges that we faced when we introduced our server, right? We had to write code in our client application that would send the HTTP requests over to the server using the Axios library, right? Over to the server, and the server, we have to write a whole bunch of routes, right, that received those requests, right, and then did some work, and then responded with a response to the client. And that communication is asynchronous, right? And so we introduced all the notion of promises and the different syntax of using the .then syntax or using the async await, right? Because of the asynchronicity of these, right? So same thing is going to happen over here, right? When we connect from the server connecting to the database, right? These two are not the same process, right? These three things are three different processes, right, that are communicating over a network, right? Different protocols, right? The protocol between our client and our server is HTTP, right? The protocol between our Node.js server and our Mongo is going to be MongoDB, right? It has its own protocol, right? Just like SQL Server has its own protocol, Oracle has its own protocol, where those are proprietary protocols, right? That they're not open source, right? Their intellectual property, right? And how the communication happens. So yeah, and so the same challenges that we faced here, that the communication was asynchronous, same thing here, this communication is also going to be asynchronous. So again, we're going to have to we're going to have to use promises, right? And either use the older syntax, the .then syntax, or the newer, more modern, async await syntax. Okay. So we'll do that. And in the library that we're going to be using, the Mongoose library, right? It's what's going to allow us to log into the server, grab a connection to the server, and then start interacting with the server. So part of that interaction is the notion that we need to implement these two things. We need to implement a Mongoose schema and a Mongo model, right? So what is a Mongoose schema? So for those that might have taken a database course, one of the things you might have noticed is that when we started inserting data into our client here, never did we have to create a schema, right? Never we had to create a table, right? In a relational database, typically the first thing that you do is that you create a table, right? And you specify the structure of the table, right? You specify all the fields, all the data types of those fields, right? And once the table is created, then you can start inserting into the table, right? But notice that we had no such thing here, right? There was no table or schema. Nowhere did we declare the structure of the data, okay? And so some of you might have balked at that. Says, wait a minute, right? It's important to have tables. The importance of tables mostly, right, is to provide validation for the data, right? So that when you insert data into a database, right, the database server validates the data against the schema, against the table declaration. It makes sure that certain fields are some strings, right, that they're integers, or they're dates, or they're booleans. It verifies that the data is sound, at least it has the correct format, right? No such thing that we do here, right? And the reason is that in non-relational databases, the philosophy is that they are not going to be responsible for the validation of the data, right? You could absolutely work with unstructured data, right? There might be, the structure might need to be discovered, but we still need to store it, right? But we don't know what the structure might be. Instead, that the responsibility of validating the data, right, in non-relational databases, the responsibility now falls on the application side, not on the database side, right? So in this diagram, right, the schema in a relational database would live in the database. But in a non-relational database, the schema is the responsibility of validating the data using a schema is on the application level, right? In our application, right? We have to code it ourselves, okay? So that's what the schema is going to do. We're going to do that first. Once we have the schema, right, we're going to provide a model, right? We implement it, and we'll get there in a minute. So first, let's focus on that. Let's create a schema, right? So, okay, so let's bring up our IDE. Okay, and we'll bring up our node server. Let's see, for some reason, this is 5610. 5610, it's this one, right? Yep. Okay, and we'll need GitHub. Okay. Right, so this is where we left off last time, and we have, let's see, what branch were we? I think we're in the A6 prep. Okay. Git status. Okay, git users. Okay, git add. I'm going to switch over to another branch. So I'm going to do git checkout main. And we're going to do git checkout project. Oh, yeah, project. No, A6, sorry, A6. Minus B, A6. Okay. All right. Okay, so yeah. So let's first create the schema of the collections that we are going to be using. Right. So just like we did for the courses and the modules, right, in the prior assignment, right, we're going to create a folder for each one of the data types, right, that we are going to be working with, right? So we already have for courses, we already have for modules, right? I'm going to create one for users, right? And we want to be able to retrieve those users that we have in the database. So here we're going to have 4 files, right? One of them is going to be the schema, which we are going to use to represent the structure of the data, and it's going to be useful for validating that the data that we're storing in the database is sound, right? That certain fields are dates, certain fields are strings, other ones are integers, and so on and so forth, right? So the way we do that is we use Mongo, right? Mongoose, right? The Mongoose is a library that is going to allow us to communicate with Mongo. First, we need to install that. So is npm install Mongoose. Yeah, I'm trying to make this a little bigger. So it's installed. And once we have that, right, we will create the let's create the schema for the user. We'll describe what are the fields and the data types for the users. Okay? So let's create that. So we'll have we'll import Mongoose, and then we will create the schema. We'll say const schema is new Mongoose schema, right? And the fields that we have, right, are going to be based on the fields that we have here, right? Username, password, first name, last name, email, date of birth, role, right? So let's do that. We would say we have username, which is a string. Oops. We have a password, we have an email, we have a role, yep. We have a date of birth, which is a date. What else we have? We have first name, so first name. We have a last name, and I think that's it. Okay, and then we're going to export the schema here. We'll have the schema. Okay, all right. So this kind of declares the structure of each one of the documents that we are going to be interacting with, right? And it's mostly, or most of them are strings, right? But certainly we have other data types. I would say, we could say, salary, maybe salary, and it's of type number, right? We could say whether they're married, perhaps, right? And that it's a Boolean. So these are all data types that we can use to represent users, right? Now, the idea of a schema in general, right, is to declare data types of the fields, declare the fields and declare the data types. And in general, those are called constraints. We are constraining the validity of the data, right? And for instance, one constraint is that it needs to have a username field, and it must be of type string. Same thing, emails field needs to be of type string, and so on and so forth. But we can add additional constraints. Right? So for instance, one typical constraint is that we would require certain fields to be there, but some of them would be optional. So that's a constraint. So for instance, if I want to constrain more the username and say that it's required, right, to add additional constraints other than the type, we can do that by providing here an object instead of just the data type, right? We can say that the type is of string. So this is equivalent to just saying string or type string. But in an object, I can add additional constraints. I can say that it's unique, right? That the username has to be unique. It can't be that two users have the same username, right? So that's a constraint. Right? Another constraint is that it's required, right? Meaning, if you try to insert a record or document without the username, right, I will fail it. I will throw an exception and say, no, I don't accept that document, right? Try again, right? Okay, so similarly in password, how do you define those foreign key constraints? So no foreign keys. So in relational databases, yes, you would use foreign keys to reference other documents, not here, because they're not relational. It's non-relational databases, right? The relationships would be created in objects containing other objects, right? You can do nested. It doesn't mean you can't actually implement constraints. I'm sorry, foreign keys. You can absolutely create foreign keys, right? But it is not the main focus of non-relational databases. And I will show you how to create those relationships a little bit later. So passwords, similarly, we want to constrain and say that not only are they type string, but also they are required, right? They don't need to be unique though, right? It is okay for passwords to be the same, right? My password could be the same as your password. I don't know, because I don't know your password. Right? But both of them are required, username and password. But usernames need to be not only required, but also they are unique. Emails, we could constrain the regular expression, right? That and you can absolutely create a regular expression and say, only these characters are allowed or something like that. Salary, you can provide default values. Like for instance, you can say, that the type is number, and you can say that the default salary, is 75,000. Okay. Married, you can say that by default, it's the default is that it's false, right? So default false. Dates, you can have maybe date of hire, right? You can say that it's a date, and by default is today. Today is your hire date. When we insert the record, that's the value of the date of hire. Okay. Roles can be strings, but it can't be any string. We can limit the valid value of roles, right? So we can say that yes, it must be a string, but it can only be from these valid enumerated data types. Enumerated enum, admin, user, something like that, right? I'm going to use caps here. Admin, user, you'd be also faculty, right? And students. Okay, and the default is that you're a user, like that. Okay. So there's our constraints. One other configuration that we'll probably need is to tell it exactly where to store. Where do we want the data to be stored? And we already created a collection, right? That we have been storing the data in there, and the collection is called users. So here we can specify that all this is going to be stored in a database called users. Everybody good? All right. Okay. So following our map in the assignment, we're now going to need a model, right? The model. So a model, it's the equivalence, right? If you've done some relational databases, it's the equivalent of an ORM, right? An object relational mapping object, right? Which is it's a generic object, a model here in Mongoose. It's a generic object that if you give it the schema, right? Given the schema, it will know how to interact with the collection declared in that schema, right? It will implement the restrictions, the constraints of the schema, right? It will know how to send the commands to the database to retrieve data, to create data, right? And while it's creating the data, it will validate that the data that you are trying to insert, right, is valid, right? It will compare it and confirm, right, that it is the structure that is declared in the schema. If it doesn't, right, it'll fail it, throw an exception, right? It can implement all the CRUD operations for that schema, right? Creating, updating, deleting, retrieving, all sorts of ways of retrieving from the database. So we're going to cover some of the functions that in the model. I mean, there's dozens and dozens, right? We're only going to cover the most common ones, right? That you can build 90% of everything just with these few commands, right? So let's do that. So to implement the model, let's create another file on the users, and we have a model. And we just have to specify that the schema for which the model is being created. Right? So we can do import the schema.js, and we can import Mongoose. And bcrypt is a nice library for encrypting passwords. Right? We're not going to be using it, but certainly it'd be a great addition to this. So let's create the model. So the model is basically that we just declare Mongoose model, and to give it the schema for which we are creating the model. And it'll enforce all the restrictions, all the constraints that we declare in the schema, and will store and retrieve data from the collection that is declared in the schema. And it provides all the functionality for interacting with that collection. And we'll export it. Now, notice if you look at the model dot, right, it has all these functions. It can delete. So all the functions that we were playing around with manually at the command line, being able to find, right, has a whole bunch of find methods, find one, find by ID, right? It has for creating, inserting objects into a database. It has for deletion. You can delete one, delete many records, right? You can update records. So all the CRUD operations are available in the model. And because it's using the user schema, right, it knows that all those operations, all those CRUD operations are on that particular collection. Okay, right? And also this name here, there's a string here that Mongoose. No, we don't need this. There's a name here, right? There's a string, which that string, it's arbitrary. You can put anything you want there, right? But the common thing to do is to use a description, right, of the model, right? And I like to use the name of the collection. It does have to be unique across the Mongoose instance. If there's, for each Mongoose instance, when you declare a model, there can only be one users, right? So it has to be unique. And it'll become relevant a little later when we start creating relationships. But just for now, just remember that it needs to be unique. Okay, so once we have that, we can now start creating, right, the operations that we want to do with Mongoose, with interacting with the users. Right, so let's do that. Now, to do that, it's a good practice, right, in software engineering in general, right, but in database in particular, right, that all the operations that we implement when interacting with the database, right, that they are all collected in one file or a set of well-understood or well-known files that collectively are called DAOs, right, or data access objects, right? And so these are files that have the specific role of interacting with the database, right? Using the, whatever mechanism we have. Now, the mechanism that we have to talk to a database is the model, the Mongoose model. That's the one that has all the native low-level database functions, right, to talk to a database. But those are very low level, right? They're very generic. Instead, the DAO, right, the design, it's a design pattern, it's a well-known design pattern, is that here you create high-level functions that are specific to your application, right? So you implement several use cases that your application needs, right, to do whatever it needs to do in terms of the lower level APIs for the particular database, right? And what it does is that it at first it provides a more meaningful interactive API that allows you to understand what it is that you're accomplishing when you're talking to a database. And also it creates a single point of maintenance, right? That when you maintain or you debug anything that has to do with database access, right? There's only one place that you have to develop and maintain over time, right? But it also allows you to decouple, right, the low-level idiosyncrasies of a specific database that you're using, right, and provide a higher-level API, so that if tomorrow you decide to migrate to a different vendor, right, and you decide that you don't like MongoDB anymore, you want to do Postgre or MySQL or whatever, right, you can focus most of your effort of migration to the DAOs, right? Where you just re-implement the functions in the DAO, and so that they deal with the new version of the new vendor, right? But the API to the rest of the application upstream, right, that is unaffected, right? So that as long as the rest of the application is using the DAOs and that interface, right, though that application is shielded from any modifications downstream to the database access communication, right? So that you don't need to any changes to the data layer, right? They don't trickle over and spread out across the entire application. Okay, so yeah, so it's a very good design pattern that we should follow, right? So here we have a DAO, an example of a DAO. So let's take a look at that. So let's implement in the users. We'll create a DAO here. DAO. So we'll need the model. So we'll import the model. So import model .js, right? And here we'll have all the various operations that we need to interact with the database, right? So for instance, we'll want to implement, be able to retrieve all the users, right? And so implemented with the model, we can use the model.find, right? So model.find. So this .find, right? This is the equivalent of us typing at the command line, right? In here, right? That is the equivalent of typing users.find here, right? And it retrieves all the users, right? So that's the equivalent of that, right? So this will allow us to retrieve all those users, right? There's a whole bunch of these. So you can say, we can do export const find a user by their ID. And let's not implement just that just yet. All right, let's just list them here. There's by username. There's maybe by credentials, where you can pass in a username and a password, right? You should be able to also create a user. You can provide a user object and it gets inserted into a database, right? You can update a user if you give me the ID of the user, and the new user, I will update it or delete the user, right? So those are all, not all users. I'm not going to delete all the users. And so these are most of the most common operations that we will need. Of course, you can build many more, right? But let's visit each one at a time, right? So let's look at this one, right? retrieving all the users, right, using the low-level model.find, right? Now, these functions, right, that interact with the database, these functions are asynchronous, right? So any communication or use of these functions, right, they will have to deal with promises, right? Either using the older .then syntax or using the more modern async await, right? So for that, right, so let's see if we can implement that, right, and invoke this, right? So let's do this from an API, right, a RESTful API. So let's create a whole bunch of routes here, right, where we can implement at least that one find all users, right? So we'll need to import the DAO here from the DAO, right? And we'll implement the route. So we'll say a function user routes, right? We'll take the instance of Express and we'll implement a RESTful API that allows to retrieve all the users, right? So app.get, so we'll do one of them, API users, which we'll do DAO. Oops, yeah, that's good. And we'll close that. Yeah, so that's a good implementation, right? And we'll export this. But I find that hard to read, right? So I'm going to move this to a separate function, or move this to a separate function, call it the find all users, right? And let's implement it here. Equal that function that we just created, okay? So I just moved it out like that, right? Although I don't like this older syntax, so let's rewrite this using the newer syntax, right? So I'm going to say this async, right? And the newer syntax would say, const users await, right? And then like that, right? That's much more easier to read. I think that's much easier to read, right? So basically, when the request comes in for all the users /API/users, we'll call this function, right, that receives request response, uses DAO to find all the users. Once it has the users, I'm just going to respond with those users. Make sense, right? And then basically the last thing is that we need to add that route that we just created. We're going to say import the users routes, right, and then pass in the app. And finally, right, and the most important part is that we need to connect to a database. We're not even connected to a database, right? So to do that, we can import Mongoose, right? Mongoose, and then just connect to that database, right? There it is, right? So we're going to connect to our database is called Canvas dash what was it, CS 5610 and fall 23, like that, right? Also, by default, it wants to connect to localhost. That won't work. You need to specify an IP address, and the IP address of our local machines is always going to be 127.0.0.1. But it could be an IP address of any Mongo instance running anywhere in the world, right? As long as you know the IP address, boom, you can connect to it, right? All right, so let's run this. So let's do nodemon, or like somebody called it today, no daemon. Okay, so that starts the server, and let's go to a browser. We'll do a localhost 4000. And I believe it was, what is it, API/users. And there it is, right? So these are the users that we created earlier, right? There's a salary, right? We have the usernames, right? We have the IDs. Notice the IDs are represented here as strings, right? They're not represented using the OID, right, of the object ID data type that is used in Mongo. They're just converted into the string representation. Okay, that makes sense, right? So now we could just build a user interface, right, that uses Axios, right, to build a client, right, to go fetch this from the server, right, store it in a state variable in the user interface, right, and then iterate over that state variable to represent and render all these users, right? Okay, we'll do that later. First, let's focus on how do we interact with the database and make this available, right, through a RESTful API, right? Yeah, so we looked at finding all the users, find all users. So let's do another one. Let's practice a few of these. Okay? Another very common operations is that I want to retrieve a user by their primary key. It's a very common use case, right? So we could do this. We could do model dot find and then provide a filter, right? A where clause that's saying that I don't want all the users. I want only the user whose primary key, right, is equal to ID. Okay, so notice the curly brackets there. It's an object that we're passing, right? We're passing the properties that we want to pattern match. Okay? And so yeah, so let's do that. And so in the route, we can implement that as like this. We can say app users, we provide the ID of the user, right? And we'll call a find user by ID, right? And we'll implement it here. So const find user by ID, which is going to use, we're going to parse the ID from the params. Is going to use it for calling the DAO, right? And then we're going to respond with the user like that, right? So yeah, so we should be able to now go back here, right? And if we know the ID of a user, right, of Arwen, you can say provide the ID here, right? And it returns an array of that single object of Arwen. But notice that it's an array, right? Even though we know that, since it's a primary key, we would be expecting a single object, right? But that is the case of whenever you're using find, whenever you use find, you're always going to receive an array, even if it's a single object, okay? But since retrieving things by a primary key is such a common use case, right? It's really inconvenient having to have this in an array, right? I know there's only one item in that array. So you're forcing me to unwrap this array, right? To access the first element, the only element in this array. So it's inconvenient, right? So to make it a little more convenient, right? There's a different version of this, right? There's a different version, which is model.find by ID. So find by ID expects you to just pass the ID. It knows that you're comparing against the primary key, right? So there's no need to provide the additional format like that, right? It knows that you compare against the ID, and also it has the convenience of doing the unwrapping for you. See that? It's just you just get the object, right, without the nested array. Okay, so it's just more convenient. It's only for convenience purpose, right? So for your username, same thing, right? You can ask for a find, right? And then we can provide the username like that. And so username, right? So it says so we are filtering by the username, right? Where the field username matches the username. Right? So we can create a non-RESTful API, right? So we say app.get username, yep. And we'll provide a function called find by username, not the DAO, right? And so const find by username is going to parse the username from the path. You're going to call DAO, find user, and return that user like that, right? Very good. Notice that this is not RESTful, right? If we are usually the only thing that should be in the path should be only primary keys, right? Not usernames, unless username is your primary key, then this would be okay, right? But in our case, usernames are not our primary. It is a unique key, but it's not primary, right? So yeah, this is not a kosher RESTful API, right? But nevertheless, it works, right? So it's it's academic. We're just learning this, right? So let's retrieve all the users, and so we should be able to filter and retrieve, Bruce Wayne, right, by it's his username, right? So we'd say users, username, Dark Knight, and indeed it retrieves Bruce Wayne, right? But notice that we know username is unique. So ideally the username should be sent in the request body, right? Either in the body or as a query string, right? A query string username equal username, right? So when you're filtering by anything other than the primary key, it should be either in the body or the query string. So we know that the username is unique, right? So we knew that we were going to get one object, right? So it is somewhat inconvenient that this is inside of an array, right? So similarly, like we did earlier, right? When we know that it's just one, right? We can use another version of this. We can say model. We know that there's only one of these, right? So there is a syntactic sugar version that already unwraps that single object in that one array. It unwraps it and it just gives you the object instead of just an array with a single element, right? Which is silly. So if we refresh that, notice that we do get just one object, right? We can also filter by multiple fields, right? And again, since one of the fields is a unique field, we would expect only one person having the combination of username and password, right? So already we're going to use it correctly. We just use find one and provide the username and the password. Now notice that I've been using this syntax of providing username : username, but as you know, right, in JavaScript, since ES6, when the property and the variable that we're using in an object, when they use the same identifier, right, this can be collapsed into just using username like that, right, or password, right? Okay, so don't freak out if you see that syntax. It just means that it's username : username, password : password, right? But it's a more compact way of representing it, right? Okay, so coming here, we can implement that, saying that we want to implement app.get, and we say users and provide the credentials, right? And we'll provide a function called find user by credentials implemented here, right? We would say const find user by credentials. I'm going to parse in the username and password. Otherwise, we can do it this way. So we say username and password from the request params. We're going to use the DAO, find the user, and respond with that single user, right? Not DAO. It's this function right here, calling DAO, right? Does that mean we can see the password in the URLs? Absolutely. Yeah, so don't do this. Yeah, don't do that. So the proper way of doing this is using post, right? And we'll do that in the next lecture. My focus right now, right, is to learn how to interact with the database, right? Using proper URLs and whatnot. We talked about that last week, right? The last couple of weeks we've been talking about, when to use posts, when to use get, when to use path parameters, when to use query parameters, and we will use the correct things. I'm just right now focusing on, interacting with the database, right? And I'm using gets everywhere, right? Because otherwise I would need to create a user interface. I would use to create a post, to create a delete, to create a put, right? And that would just complicate the whole notion, the whole explanation, when I only want to focus on talking about interacting with the database, right? So I'm quickly throwing in URLs in here, even though we know it's not kosher, right? We'll come back and fix this a little later and use post and delete and whatnot in a bit, okay? So yeah, so add credentials. So that's we're going to implement that. It's going to pass in the username and password. But excellent, good points, excellent. Thank you. User. So let's do that. Let's check to see if this works. So I can pass in several. I can pass several parameters by which I can filter, right? And so yes, let's try that. So we have maybe let's find someone else. Romanov. So we have a username. And the password is Romanov123, right? So you can say users, credentials, username, and then it's Romanov123. So it returns just that one user. Very good. But I mean, there are legitimate times where we do want multiple users, right? For instance, if we want to implement, export const, find users by role, right? So this one does make sense that we use a find, right? Because we know there are going to be multiple users with the same role, right? Which makes no sense to use a find one or find by ID. This totally makes sense to use find, right? Which is going to return an array of objects, right? So let's implement that. So for instance, you might say, app.get, and so this would be, API / users role, and then provide the role like that, right? And so we're going to find users by role, not the DAO, right? So we'll implement here, const will expose the role, grabs the DAO, and here's the users. There we go, right? So now we can try that out, right? And we can say, users, and then say role, and then the role is maybe admin, returns only one, right? Which is fine, or only the faculty, right? So there's all faculty, or the students, right? Returns all the students. Make sense? All right, and finally, right, so these are all read operations, right? And you can think of many, many different types of, read operations, right? And it's only the R in the CRUD family of operations, right? We still need to implement create. We just did a whole bunch of reads. We need to implement updates, and we need to implement deletes, right? So let's take a look at that. So let's head over to DAO, and let's implement create, right? So to create, model has a function called create, right? That will insert the user object, raw, right? It will validate it against the schema, right? And if it's okay, it'll insert it into the data. If it doesn't, right, it will fail it, and give you an exception. Why did it fail, right? So let's implement that. So we'll implement here a create. So const and create user, and so typically this would be in a post. The post would send a body with a JSON object that we want to insert. But for that, I would need to create a user interface that uses JavaScript that collects all that, right, as in a JSON object, and then sends it. So I'm not going to do that for now. I'm just going to parse from the params. I'm going to pass it in the params. And then I'm just going to pass in the create user. I'm going to pass in an object that has all those things in the path parameter, and then I'm going to respond with the new user. So this new user, right, created by the database, right, is the actual object that was inserted into the database, including its primary key, right, its unique primary key, which I'm not providing. Right, only the database is now going to be responsible for computing the unique primary key, right? I'm no longer going to have to deal with that, right? Although we could configure the schema so that we are responsible for that, but it's not worth it, right? It's just a better role to leave out to the database, right? Anyway, so there it is, right? I'm grabbing the parameters, which includes all these fields, right? I'm parsing them out, right? And then I'm using it to build a JSON object that I'm going to send into the database, right? So yeah, so we can now maybe copy one of these, or we can, we can create our own, I guess. So, app dot get, and then we're going to encode here, API / users, and I'm going to provide in that order, I'm going to provide the username, the password, the email, right, and the role, like that, right? I'm going to call create user, right? And that should insert into the database, right? So let's try it out. So we can say user, and I'm going to provide in that order. I'm going to provide the username. I'm going to say Bob 123, the email Bob at marley.com, and the role is a faculty, right? So notice that comes back from the server, right? And with the various fields all populated, right? The username, the password, and the email, the role, right? Not married, okay? The ID, the date of hire has a default value, right? The default salary, right? Married, default value, and the primary key. It has an additional field in here, V, underscore V. That's added by Mongoose, the library Mongoose, right? That it's used for all internal purposes, right? For managing versioning and things like that, right? So yeah, so we can create records, right? If we go back and refresh, we should see that has been added here. So if we look for Bob, oh no, this is the students. I want all of them, so all the users. And so in here, we should see Bob. Yeah, there it is. So Bob has been inserted into the database. Perfect. The other thing that we can do is update a user, right? So we can say model, and there's an update. So update, there's a few. There's update one record, right? We know that there's perhaps by a primary key, or if we're updating several, maybe we're giving everybody a salary raise. So we're updating everybody and giving everybody, 10% salary raise, right? Or we're updating one person, maybe that we're updating somebody's password, right? Or whatnot, right? So let's use update one. And update one takes two arguments. The first one is a filter, right? That allows us to identify which document we want to modify, right? So typically it's by primary key. We say, oh, well, it's the user whose ID I'm providing here as an argument. And then the second argument is, what do you want to do? Once you find that object, what do you want to update? Which field do you want to update, right? So the easiest thing would be that we provide an object with the fields that we want to manipulate, right? With the new values. So the field and the new value. And then here we can use a function called set, an operator called set, right? What we'll do, right? It will pattern match, right? The fields that are provided in this JSON object, and will update that particular property in the database with the new value that you provide in that object. Okay. All right. So let's do that. Let's create here I want to change somebody's first name, right? We can say app.get, and so I'll provide ID, users, update, and then the ID of the person, and then the new. So we'll call this update name, or first name, something like that, right? And so we'll say new first name. Right, so I will call this, update first name, right? So let's implement this. So, update first name. I'm going to parse the ID of the person, and I'll update the first name, right? And I'm going to use update, and I'm going to provide the ID of the person, right? And then the first name field is going to be updated by first name, right? Like that, right? And then the response actually that comes back from the server, that comes back is actually not a user. This is a status telling us whether the update was successful or not, right? Were there actually any fields that were updated, right? Did it fail for some reason because the format was correct, right? It's just a status, right? So let's try it out, right? So that's the URL. So let's change Bob's first name. So Bob will change it to Robert, right? Oh, actually, no, we don't have a first name, do we? Anyway, doesn't matter. It will add it. If we start changing it, it will add it, right? So let's do that. So we'll say users, we'll say update. What was it? Update. Let me copy this like that. Update. So the new first name will be Robert, and the ID. This is the ID. Like that. So it'll be Robert. Uh-oh. I think it failed miserably. What happened? Robert. Uh-oh. Did it crash? Actually, yeah, it did crash. What's going on? Not defined, blah, blah, blah. ID is not defined. Ooh. Oh, yeah, that's wrong. My user interface, my AI died. So no, this is ID colon ID, not ID comma ID. All right, let's try it again. So let's refresh. Okay, there we go, right? So it came back saying, yep, I got your request, right? I did modify one record, right? It matched one record. I modified one record, right? And if I go back and I refresh for all the users, right? And I look for Bob again. There it is. First name is Bob, is Robert. See that? Which it wasn't, right? Let's change this name, right? So let's see if it's true. We'll change it to Pedro instead of Peter, right? So I'll change no, wait a minute. What's the URL? It's so I'll copy that again and paste that. So I'll change Peter's first name. So I'll change here's the ID, right? And the new name is Pedro. Pedro. That, right? So we'll go back and refresh, and there it is. Pedro changed. See that? So yeah, so we can change records. We can change multiple fields, right? We can, you can imagine that here, instead of just passing one field, this could be a post, right? And this post can receive a body with all the fields that you want to modify, right? So you can modify multiple fields at the same time. All right. And finally, we can delete, right? And where we can provide the ID of the record, right? And use the model.delete one, and we can provide the primary key of the document that we want to remove, right? So let's do that. So let's create here a get that will allow us to remove. So we'll say app.get delete ID, and it's going to use a function here, const delete. If we can type delete user, right? So this is the delete user here, right? Which is going to parse the ID from the path parameter. You're going to call the DAO delete user, and the status is going to be sent the status to be tell us whether it was successful or not, right? So yeah, so let's try it out. Let's remove Bob, right? So for instance, we could say, so first we'll try to find Bob. There's Bob, right? And we can say users./delete, and we're going to provide the ID of Bob, right? And it comes back saying, yep, I got your request. And yes, I was successful in deleting one item. And if we go back, it's still there, right? Because it's cached. This is a cached response here. But if I refresh and re-query the database, if we look for Bob, Bob is nowhere to be found, right? So yeah, so there you have it, right? We implemented all the various CRUD operations, right? With the database, right? And we toyed around with some of the implementation of the routes, right? That expose these operations, right, to a user interface, right? So yeah, so let's now explore, right? How is it that a user interface would use this? And you know, it's we already know, how to interact with the routes, right? We already, I mean, that was the whole point of the last several weeks, right? The assignment 5 that you're working right now is learning how to interact with a server, right? So let's implement just at least the retrieval of this data from a user interface, right? So let's bring on the other project, right, that implements our user interface, which is our React web app, right? Okay. Let's see where we are here. Git branch. Yeah, we're A5. So let's check out and start A6. Right? And so let's implement. Let's implement. What? Wait a minute. Wait, am I in the right place? We are code file recent React web app. Okay, yep. And what branch am I in? Yeah, actually, let me switch over to project. Git check out project, actually, project. So that you already have all that material there. All right, so you have project here. Yeah, so let me implement it inside of project. All right, let me create a directory where we're going to deal with everything that has to do with users, right? So we'll say users, right? And for instance, one of the things we might want to do is display a list of users, right? So we'll create here list.js that creates a list of users, right? So we'll do an npm start, so it's up and running, and we can close that. Oops. So let's bring that over here. Okay. And so let's navigate to a place where we can see the list of users, right? So for that, right, let's create a route that allows us to go there, right? So we have the hyperlinks. We have we'll create a list here. We'll do a function user list that returns a list of users, exports this, and then we'll have a route here that can say route path users, right? And then renders an element will render the user list. Okay, like that, right? And we can have a link that allows us to navigate to users. And this will be maybe project users, right? All right, so from here, presumably we click on users and we are in the user list. Everybody good? Okay. So in there, in the users, in the user list, what do we need? Well, we need to be able to connect to this URL, right? We need to be able to connect to this URL, right? This one, where is it? Here, right? This URL to retrieve the users. And we know how to do that. We know how to do that already, right? We can create here a client application, right? That knows how to connect to the URL, right? We can create an EMV, right? Right, we already have a base, right? We already have a React app API base URL, right? So we can declare that const API base and bring in process. I think that's the name, right? Is that the name? Yeah. Okay. And so users is where? Users is users API is that API based /API/users, right? That's the URL of where it lives, right? Right here we have the base. This is the base, right? And then we're just appending API and users at the end. Right? So that's how we're going to talk to that URL, right? And then now we can implement the with Axios. Let's import Axios. So import Axios, and we can implement, const, find or export const find all users, as a sync, get users, right? Axios.get users API. Perfect, right? So now in our list, right, we can declare we can import that, import star as client from client. We can declare a state variable that can hold the users, and we'll need a const fetch users that uses the client, find all users, and stores them in the local variable. And then useEffect can then call fetch users and populate that array, right? And we'll need both the useEffect and the useState so that we can then do the users here. We can iterate over the UL as a list group, right? And actually not UL, I'll say do a div, right? So that we can iterate over the users, create a link, right? With the user, he is user underscore ID, right? Maybe a hyperlink that allows us to navigate to that particular user's profile, right? Display the username and close the div. I think we have to close the div here, right? Like that, right? All right, so let's see. Where's that? There it is. Let's see, where do we fail? We are in the projects 404. Let's see. In the network. Refresh. We go to users. Where does it fail? Okay, users. What is the header? Okay, this is HTTP localhost 3000. Oh, that's wrong. 3000? That's wrong. Why this is 3000? And local 4000. Did I import the wrong one? Oh, base URL. That's right. There we go. It was null, so it just filled in the 3000, right? The default one. There we go. There's our users. See that? It brought in all the users: Alice, White Wizard, Even Star, Lady of the Light, right? And all the various users using just displaying just a username. Okay. The next one we would want is maybe, if I click on even start and go, slash users, and I click on this, right? Slash profile, right? Maybe we want to fetch that specific user, right? So let's do that, right? We can, so lists, the URL probably, I would like to maybe it be just uses so project / users, the ID of the user, and then create a component that can render that specific user. So maybe we can have a details file component that can have the user details, right? So return maybe div user details for now, right? And we'll export that, and then we can map it, right, to a route, right, that has the ID encoded at the end, right, that renders the details, so user details, right? And then in user details, we can parse out that ID, right, the ID from use params, and we'll have to import that. And we can, have a state variable where we have the user, which at first is null, but we can go fetch it from here, right? If we pass the ID to a find user by ID, it can go fetch the ID like that, right? Because that we know that works, right? We can here, right? If we provide the ID to that URL, it returns that one object, right? So here we can, encode that ID, returns that user, so that in details we can go fetch that. We can say, bring the service here, so import as client from client, right? And we can go fetch that user, fetch the user, right, and set the user like that. And then on use effect, we go fetch the user to populate that user, right? And we'll have to import those two, import use effect and use state. And then here we can render the object, right? If it's not null, right, we'll display the username, email, first name, last name, right, and whatnot. Like that, right? So if we come here and we go to users, there it is, right? Which allows us to now navigate from and choose any one of these. So Captain America, we get Steve Rogers, right? If we get the Hulk Smash, we get his details, right? We can navigate to any one of these and have his details, right? So the next interesting thing would be to be able to edit this, right? Be able to either delete this person or edit this person, right? So let's do that. So for editing purposes, these could be, input fields instead, right? So this instead of rendering, so let's change maybe you can change your first name, right? So let's change this to be an input field, input whose type text, form control, value is first name. We can edit it locally, right? And then when we click on an update button, we would do the update, right? So the export update user, which would be a put, right? Which we don't have, right? We never implemented that on the server, right? We don't have a put, right? So we'll need to come here and implement a put. So update here would be what? Would be, const update user, right? Which would be, we get the ID from the params, but the actual new values of the fields would be in the body correctly. And we get status, JSON update. Now notice that the database is the same, right? The database, you're just providing an object of what it is that you're updating. That doesn't change, right? The interaction with the client changes, right? Because we want it to be a put. All right, so let's do that. So it would be app.put, right? It would be like that. Okay. we encode the ID at the end, and then we include the objects in the body, right? In the body here, right? Which is what we did here, right? We're including the new user in the body, and we're encoding the ID at the end of the API, right? So in the details now, right? We're going to have a handler. We're going to say const, update user, which uses the client, right? Comes back with the updated user, which is not true, right? What comes back from the server is a status, which you don't want to use it for updating the local version, right? It's just a status object. It doesn't include any user information, right? So you don't want to do that. And we invoke it, right, when we call on a button with a primary that we call the update user here, right? So let's try it out. So we have here, we go back and say Alice, and we have the first name, so we can say, maybe call it Alicia. So update, we don't get any validation, but if I refresh, notice that indeed it has been modified, right? If I go back and I navigate again, there it is, right? If I go to the server, the Mongoose server, right, and we refresh this, we should see that Alicia has been indeed modified in the database, right? And finally, delete, right? On the server, we implemented it as a delete here, delete. But in reality, this should have been a put, right? So delete, blah, blah, blah. We have the ID from the params, yes, and we delete it. So that's correct. But this should have been a delete, right? So this should have been a delete, right? And no verbs, right? No verbs here, delete user. Very good. So that on the client, right, we implement the delete, so export delete user, we encode the ID, right? The response is just status, right? And so in the details, we could have a button down below that deletes, right? So we would have a function here that we can pass in the ID of the user, right? And we are going to call the ID, the status. There is no update, so there's no need for that. Just going to remove it, right? And so we're going to call it from a delete button. So it says button, which is delete, right? Which is going to be dangerous, btn danger, danger. Details. We're going to onClick call delete user and pass in the user._ID, right? Which is what it's expecting, right? So it's expecting the ID, which we're passing it the ID and coding at the end. And there it is, right? So if we go back here and we're looking at Alice and we click on delete, I don't know if she's really gone. Let's go to users and we refresh. Looks like she's no longer there. Find Alice. No, she's not there, right? So it has been removed. Actually, the common implementation would be that after deleting, the common thing is that you would return to the previous screen where you came from, right? So you could do that with navigate. You can say, const, you import use navigate, use navigate. There we go. And here's his navigate, use navigate. And so that you can, once you've deleted, it makes no sense to stay there, right? It's that you navigate back, right, to project user, so that if I go back and I remove another one, so I remove Thor, right? And I delete, it navigates back and notice that Thor is no longer listed here. Okay. Make sense? All right. Yeah. Any questions? In our own project, when we use third-party API, we can get the data by using URL and API key in front end. Do we need to create the model and schema for that? For example, if I develop a movie app, do I need to create the model schema down for the movie? I get the movie details from third party and display them in the front end directly. Yeah, absolutely. So for searching, for displaying, for details and things like that, for just exploring the data that is provided by the third-party API, then there's no need for the database at all, right? You don't need to store any of that in the database. It's only necessary that you store something in the database if you need to remember something about that movie, right? So for instance, if you need to say that this person has liked this movie or written a review about that movie, right? You'll need to create a instance of that object in your database, right? Now, if you can only remember if you remember only the ID, right? You'll have the problem that, say I go to my profile and I want to list, which is a requirement. A requirement is that if you go to the profile, I should be able to see everything that I am related to. So if I'm related to by a movie because I have liked a movie, I only have the ID of the movie. So what am I going to display, right? I can't display just the ID of the movie. I would need to at least display the name of the movie, right? And now if you have 10 movies that you have liked, you would then need to iterate over the 10 IDs and go fetch 10 names from the API. That would be very expensive, right? So a much better solution would be to cache that information in your database, right? And so when you do a query, it says, well, which movies do I like? It would come back with an array of objects that are already populated with an ID, with a title, maybe even with a thumbnail or maybe the ID is enough to create the thumbnail. And so now you would list in your list of things that you've liked, you have the titles of those movies, as opposed to making 10 queries, right? Retrieving the 10 movies that you liked, especially because not only are you going to like them, you're going to review them, you're going to hate them, you're going to thumbnail, you're going to, whatever, right? So those would be a very, very chatty, unnecessary queries all over the place, querying for information that you already should have in your database. So no, yeah, you have to create an object in your database and create a relationship with that object. So anytime you have in your source code, you're iterating over several asynchronous calls, that should be a red flag. Where you are in a loop, right? You're iterating over many asynchronous calls, right? So that is non-trivial. It can be done, right? But it's non-trivial. So you don't need to store the entire movie, right? Because the movie might have hundreds of fields, of which you might only care about the title of the movie, right? Maybe the director, I don't know, maybe the rating of the movie, PG-13 R or whatever, and maybe a URL that has the link to an image for a thumbnail, and maybe in the ID, right? That's probably the only thing you need. So that's going to allow you to work with your database where you have all this information cached in your database without you having to iterate over several asynchronous calls. Why do we use posts for update, not patch? Put, not post. Did I use post? No, it's put. Patch could also work. Sure, patch would work. But put or patch, mostly users of developers use put. But patch would work too. but historically put has been more common. Anything else? Oh, Katie, how you doing? Yes, sure.
Good, good. Okay, great. Thanks.
Did you want to share your screen or?
Yeah, I'll share my screen. It says host disabled, participant